Hello again YouTube, we're back today for another day of our Blind 75 challenge where we're solving 75 LeetCode problems in 75 days. Today is day 2 and we're going to solve another question that deals with arrays. This one is called the best time to buy and sell stock, and the question goes like this. You are given an array prices where prices at I is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. And we have some examples here. We've got the input of prices and the array defined, and then the output is going to be 5. And the explanation says you can buy on day 2 at the price of 1 and then sell on day 5 at the price of 6, and the total profit is 6 negative 1, which equals 5. And you can see example 2 as well. So let's think about a brute force solution. What we can do is let's iterate through the array, and for every iteration we're just going to check the profit margin between the number at the current index and then the rest of the indices in the future. So from our example number 1, we're going to take a look at 7 and then check the profit margin between 7 and 1, 7 and 5, 7 and 3, 7 and 6, 7 and 4, and then we're going to move up to 1 and then check it against 1 against 5, 1 against 3, 1 against 6, and then 1 against 4, and continue on. So let's get started. First we're going to need an integer which we're going to use to track the maximum profit. And we'll just set that to 0. And next we're going to iterate through the array once. So we're going to do for int I equals 0. And we're going to loop while I is less than prices.length. And then we're just going to increment I each time we pass through the array. And then we also want that inner loop. So we're going to do int j equals I plus 1. And we're going to loop while j is smaller than prices.length. And we're going to increment j each time we pass through. So what we want to do inside these two loops is just set the maximum profit to math.max. And math.max is just a method that takes in 2 integers and returns the larger of the 2. Similarly, math.min takes in 2 integers and just returns the smaller of the 2. So for now, we just want to check max profit against prices at j, negative prices at I. And then when we've came out of both of these for loops, we just want to return the max profit. And let's run that. And we can see the answer has been accepted. But we can still see that this is kind of inefficient. We have 2 for loops, which is a good indicator that this algorithm runs in big O of n squared time. So when you're solving these kind of problems, it's good to think about what is the realistic runtime that you can get this down to. In most cases, when you're iterating through an array, you can almost always get it down to 1 for loop, which would mean that we just visit each node in the array 1 time. And by doing that, we can cut it down to big O of n time, which is of course much more efficient. Your algorithm will run much faster. So let's think about how we can achieve that. Well, we're already tracking on the maximum profit. What if we could track the minimum price that we visit? So what we can do is get rid of this for loop and let's instantiate another integer, and we're just going to use it to track the minimum price. We're going to set it to the first integer that we come across, which will be at index 0 of prices. And let's create another for loop. We're just going to use int I equals 0, and we're going to loop while I is less than prices.length, and we're going to increment I each time. So next, let's check for the minimum price. So we're just going to set minimum price equals to math.min, and we're just going to compare minimum price to the integer at the current index of prices. And then we're just going to check for the new maximum profit. We're going to use math.max, And we're going to check the current maximum profit against prices at I negative the minimum price. And we can see that this answer has also been accepted. For this one, we're only iterating through the array one time, so of course that cuts the runtime down and makes it much more efficient. One last thing that we need to check is a edge case. So what if prices was given as an empty array, or how about if prices was null altogether? Of course, these are things that you should be asking before you write any code, just as a way to gather requirements. So let's take care of that edge case now. So we're just going to do if prices equals null or prices dot length equals 0, we're just going to return 0. And let's run that one more time. And we can see that the answer's been accepted. So this rounds off another day of the Blind 75 challenge. If you're interested in seeing the rest of the series, we've still got to tackle more array questions, some linked lists, some graphs, some dynamic programming. It's going to be 75 days to tackle 75 LeetCode problems of the Blind 75 challenge. Don't forget to like and subscribe, and I will see you tomorrow for another question.